All right, let's go over the warm-up. On the first one, number 3, they want us to find the length of segment AB, this segment right here. How big is segment AB? 6.9. Yes, there's a congruence mark on AB and a matching congruence mark on BC. So that means AB has to be 6.9. Second part of the question, we want to find the measurement of angle BDA. So B down to D and then up to A. This is the angle that we're looking for right down here. How big would that angle be? 30 degrees, yes. In a kite, which is what this is, the long diagonal, in this case that would be BD, is bisecting those two angles. So BDA is the same size as BDC, and DBA is the same size as DBC. So the measurement of angle BDA is 30 degrees. Then we come over to number 4. They ask us to find the length of EH. How big is EH? 3.7. There's a congruence mark on EH and a matching congruence mark on GH. So EH would be 3.7. And then the measurement of angle EJF. EJF. This angle right here. How big is that angle? 90 degrees. In a kite, just like in a rhombus and a square, where those two diagonals meet, they are perpendicular, which means they create 4 90-degree angles. Measurement of angle EJF is 90 degrees. All right. Very nice work on the warm-up. The rest of our class time together today, I'm going to take any questions you guys have at all off the test review that you received on Friday. If you did not get a test review on Friday and you didn't pick one up yesterday, or you just misplaced yours, or you'd like to have a second one, it's going to be one paper up from the bottom in this red organizer over here. Yes, sir. What'd you say? How many sides does it have? That's where it came from. Yep, number of sides. All right. The review is one up from the bottom. Yep. What about the 2? It's always -2. That's the rule there. Good questions. Which problems would you guys like to see me go over? Number 1, sounds good. Let's start there. So the first thing we need to do is to find the sum of the interior angles. To find the sum of the interior angles, we take the number of sides we have, we call that n, we -2 from it, because this gives us the number of triangles we could make inside that figure, and then we multiply that by 180 degrees. It's always number of sides -2 times 180. How many sides does this figure have? 6. So we have 6 sides, which means I do 6 - 2 times 180. That would be the same thing as 4 times 180. And 4 times 180 is 720. So the sum of the interior angles of this polygon is 720 degrees. We can always find the sum if we know how many sides it has. And then we're going to add all of our angles together. That's what sum means. So the measure of angle A plus the measure of angle B plus the measure of angle C, angle D, and then angles E and F. And we set that equal to 720. And then we take the measurements that we have from our figure and we substitute them in. What do we have to represent angle A? How big is angle A? 90. So I put 90 in here in the place of angle A. Angle B has an expression to represent that. That's 2x plus 18. Angle C has another expression. We have 3x plus 2. Angle D is 151 degrees. Angle E is just x. And then angle F is 108 degrees. So I make all of my substitutions, and it's still equal to 720. And then we combine our like terms together. X is first, so here's 2 x's. 3 more gives me 5. And then this one right here. So I have 6 x's total. So 6x plus, and then we have to add up all of the constants. I have 90 plus 18 plus 2 plus 151 plus 108. Let's see, that would be 261. I think it's 369. Can somebody double check me? I just added it in my head, so I'm not 100% sure I'm correct. Can somebody check me with a calculator? Yep, awesome, thank you. And then we subtract 369 from both sides. And so I get 6x is equal to 351, not 67, 6x. I don't know why I wrote 7 there. 6x equals 351. And then we divide both sides by 6, and we end up with a decimal. What is 351 divided by 6? 58.5. And then we need to find the measurement of angle B. They gave us an expression for that on the figure. That is 2x plus 18. We just figured out that x is 58.5. So I have 2 times 58.5 plus 18. 2 times 58.5 is 117. And 117 plus 18 is 135. So the measurement of angle B is 135 degrees. What else would you guys like to see from the review? Yes, sir. Yes. What else would we like to see from the review? Yes, sir. Number 15. You want to see all of 15? Okay, because 15 is going over the stuff from the notes that should be on your flashcards, but we can go through that. So number 15, we're going to write down the name of the shape, definition, what we know about the sides, diagonals, and angles. Those are our properties, and then we're going to include a drawing. The first type of quadrilateral that we studied in detail was a parallelogram. A parallelogram is a quadrilateral with 2 pairs of opposite parallel sides. And then for our properties of parallelograms, the sides, there are two pairs of opposite and congruent sides. So I'm going to start drawing this figure so that I can add the properties to my picture. All right, so here's my parallelogram. Opposite sides are parallel and congruent. So the left and the right are parallel and congruent. And then the top and the bottom are parallel and congruent to each other. The diagonals of a parallelogram bisect each other. So I'm going to draw in my diagonals. These connect opposite corners. And the diagonals are bisecting each other. So this little half of this diagonal is congruent to the other side. And this half of this diagonal is congruent to its other side. My angles, both pairs of opposite angles are congruent. So this angle up here is congruent to this angle down here, and the lower left is congruent to the upper right. So that was the first quadrilateral that we studied in depth. All right, then what we talked about next was a rectangle. Yes, sir. A rectangle is a parallelogram with 4 right angles. So draw my picture of a rectangle so that we can fill in the properties as we go. Because this is a parallelogram, it's a special kind of parallelogram. Both pairs of opposite sides are parallel and congruent, just like a parallelogram. So I'm going to mark my opposite sides just like I marked them with a parallelogram. Congruent and parallel on the left and the right. And then the top and the bottom are congruent and parallel. Yes. Yep. Quadrilateral means that it has 4 sides. Yep. Absolutely correct. So yes, anything that's true for a parallelogram is also going to be true for a rectangle. So it's a quadrilateral and it has all the same properties for the sides, diagonals, and angles, but then it has a couple of properties in addition to that that are special for just our rectangles. The diagonals, because it's a parallelogram, that means the diagonals bisect each other. But because they have 4 right angles, that means those diagonals are also the same size as each other. They are congruent. So I'm going to draw in my diagonals here, connecting opposite corners. Each little half diagonal is congruent to all the other half diagonals because my 2 big diagonals are congruent to each other, and because they're cutting each other in half, that means all 4 little half diagonals are congruent. And then what we know about the angles is all 4 angles are right angles. So coming into the corners of my rectangle, every single corner on that rectangle is a right angle. The shape that we talked about next was a rhombus, followed closely by a square. So our next 2 shapes are rhombus and square. Right, so a rhombus is a parallelogram with 4 congruent sides. So I'm going to draw a picture of a rhombus so that we can fill it in with the properties. Because this is a parallelogram, both pairs of opposite sides are parallel. And all 4 sides are congruent. So the left is parallel to the right. The top is parallel to the bottom. But then I put 1 congruence mark on every single side because all 4 sides are congruent to each other. Parallelogram should be longer. A parallelogram should be longer one way than the other, whereas a rhombus looks more like a squished square, where all 4 sides are congruent to each other. The diagonals, because it's a parallelogram, they bisect each other. Thank you, sir. They bisect opposite angles. And they're perpendicular to each other. All right, so I'm going to draw in my diagonals. We're going to connect opposite corners. They bisect each other So this little half diagonal is congruent to this half diagonal. And then my other diagonal is also being cut in half, but it's not necessarily the same size as the first diagonal. They bisect opposite angles. So these two angles up here being cut in half, and it's the same size as these two down here. And then the two angles in the lower left are congruent to the two angles in the upper right. And where the two diagonals cross each other, it's 4 right angles. Property for the angles, because it's a parallelogram, both pairs of opposite angles are congruent. Right there. And those angles are bisected by the diagonals. So starting off with opposite angles being congruent, so these two big angles are congruent to each other, and then we've taken it and cut them both in half. That's why I have 4 little angles right here that are all the same size. Same thing with this diagonal here. These two angles are congruent to each other, and this purple diagonal is cutting both angles in half. So I end up with 4 little congruent angles here. All right, next one is a square. You have to know all the properties. I'm not going to necessarily ask you to just spit out definitions and properties, but if you don't know the properties, then you won't know how to set up the equations to solve the problems. It's also possible that, like our warm-ups for last week where we had true-false questions, you might be asked to answer some true-false questions about the different properties. But I'm not just going to have you write down definitions and properties. All right, so like I said, next shape is a square. This was the last type of special parallelogram that we talked about. A square is a parallelogram with 4 right angles and 4 congruent sides. And begin my drawing here. Sides for a square, exactly the same property as a rhombus because it has 4 congruent sides just like a rhombus does, and it's a special type of parallelogram. So both pairs of opposite sides are parallel. And all 4 sides are congruent. So I'm going to mark the sides just like I did with the rhombus. The left is parallel to the right, and the top is parallel to the bottom. All 4 sides get 1 congruence mark each because all 4 sides are the exact same size. My diagonals, we have a whole lot going on. Because this is a special type of parallelogram, my diagonals bisect each other. This is also a special type of rectangle because a rectangle is a parallelogram with 4 right angles. This is also a parallelogram with 4 right angles. So my diagonals are congruent. This is a special kind of rhombus because we have 4 congruent sides, so they are perpendicular. And they bisect the angles. So there's a whole lot going on with our diagonals here. So let's go ahead and draw those diagonals in, connecting opposite corners. So all 4 of my little half diagonals are congruent to each other. That's because they're bisecting each other and those 2 full-length diagonals started off the same size. They're perpendicular to each other, which means right here at the center we have 4 right angles. And then each of my corners is being cut in half. But because I have 4 right angles, that means all of these little half angles here are 45 degrees. My angles, all 4 angles, are right angles. And are bisected by the diagonals. So I'm going to go ahead and mark my 4 right angles. We already marked that they're being bisected by those diagonals. And so when I take 90 degrees and I cut it in half, I bisect it. That's how I get the 45 degrees for every single little half angle there. The last 2 types of quadrilaterals we talked about were not special types of parallelograms. We talked about trapezoids, but we specifically talked about the properties of isosceles trapezoids. So that is our next shape here, an isosceles trapezoid. Definition for an isosceles trapezoid: this is a quadrilateral with one pair of opposite sides parallel, and the other pair congruent. Those we refer to as the legs. The sides that are opposite and parallel we call the bases. I'm going to draw my trapezoid over here. There's my isosceles trapezoid. For my sides, one pair of opposite sides are parallel. So in the case of this particular picture, that would be the top and the bottom. And the other pair of opposite sides is congruent. Those are the legs. So this side and this side. The diagonals of an isosceles trapezoid are congruent. They do not bisect each other, but they are the same length. So when I draw in these diagonals, one of them is the same size as the other one, but they are not cutting each other in half. And they're not necessarily forming right angles there. It's possible that they do, but it's not a requirement for an isosceles trapezoid. And then for the angles, base angles are congruent. These are angles that touch the same base. So my base angles would be these two down here that are both touching the bottom base, so those are congruent to each other. And then up on the top of my trapezoid, those two angles on the top that are both touching the top base would be congruent. Non-base angles are supplementary. Non-base angles are angles that touch different bases. And then the very last shape that we talked about that I mentioned a moment ago is a kite. All right, let's talk about this last shape now. A kite is a quadrilateral with two pairs of adjacent congruent sides. So I'm going to try to get a kite drawn here. All right, there's my kite. We have two pairs of adjacent congruent sides. So with the way I drew my picture, these two top sides would be congruent to each other, and these two bottom slanted sides would be congruent to each other. For my diagonals, The shorter diagonal is bisected. The longer diagonal is bisecting opposite angles. And they are perpendicular. So drawing in my diagonals here, top goes to bottom, left goes to right. That shorter diagonal, which would be my left-right diagonal, that's being cut in half. The longer diagonal, the one that's going up and down, is bisecting the top angle and the bottom angle. And where these two diagonals cross each other, it's forming 4 right angles. For my angles, one pair of opposite angles is congruent. In this case, that would be the left and the right are congruent to each other. And the other pair of opposite angles is being bisected by the longer diagonal. All right. I know we didn't have time to go over any other questions because this one took quite a bit of time. I am posting videos from all of my classes, so if there's a question that you have that you can't figure out the answer to, you looked at the answer key that's already posted in today's module and you don't understand how I am arriving at that solution, please check out the videos from my other class periods, 1st, 2nd, 5th, and 7th, to see if maybe I covered that question in one of those other classes. I want to show you very quickly, right before the bell, where the answer key is. So if you go into Canvas, go to our Canvas page, you would click on Modules. You have to scroll all the way to today's date, Tuesday, March 5th. You click on the page. It's not just located in the module. You have to click on the page and then scroll all the way down to the bottom. Right down here is the Module 7 Test Review Solutions. So please make use of that. Send me messages in Canvas if you're confused. Make sure you check out the videos for other classes if you have specific questions over problems that we did not get to.